Hello, everyone, and thank you, Mark. My name is Ulrik. I work in the NSO CTO team. Despite the early hour, I'm really happy to be here with you, and I hope we can have an interactive session. I'm looking forward to take questions in the Q&A session after this presentation. I'm sure many of you have questions on performance and how to scale with the NSO. It is a hot topic these days, so don't be shy to ask any questions in the chat. Today I will try to answer the initial questions around NSO and scaling, but will be far from able to answering all of them. This is a really hard topic, and this is a journey we really would like to be with you. My intention is to help you ask the right questions around this topic, to help you identify when to scale and where to start. Finally, I will touch briefly on our current work on best practice and what we do to help you understand what is going on inside your system. Before diving into it, I'd like to start and explain the core concepts. But before, just a few words of wisdom. And this is where we think NSO makes the big difference. Here we have a poll. How many of you have ended up with systems that are too complex to manage and too expensive to maintain? Please answer this question and we will get back to you with the answer. In the perfect world of automation, everything is automated. You take a service intent, you feed it into NSO. NSO will transform that intent into network configuration and it is pushed out to the target devices. You will get an immediate feedback if it was okay or not. If something went wrong, NSO will automatically revert and no changes will be rolled out. Due to this feature, you will know that the network is in the same state as it was before initiating the intent. These are the core strengths of NSO and what we think it makes it easy to use. So our recommendation to our new NSO user is to leverage this feature, and this by selecting a simple use case with known boundaries. Be sure about the requirements and make sure it works before continuing with the next use case. This is of course simplified as all software projects involves a lot more things than that. When you see the benefit of orchestrating and managing your network with NSO, you add more devices, you create more services, you put more responsibility onto NSO, and at some point, the business requirements will eventually exceed the performance of your current NSO system. What happens when that simple strategy of using atomic transactions cannot fulfill the changing requirements? And what are the reasons? Longer commit times reduces the transactional throughput as a new device type added to NSO may have a long commit time. Larger number of devices causes CDB to grow. Intermittent network failures causes commits to a large number of devices to fail. The service create code can take a significant time to execute. These are just a few reasons. To deal with this, in NSO, we have layered service architecture and commit queues. Later today, there is a presentation on observability in NSO, which I recommend you to see. I will not cover any spoilers, but I think this can be a source to actually find ways to optimize parts of your NSO system. Let's start with a few words about commit queues. They have been around for a while, just for the single purpose of increasing the transactional throughput. Commit queues decouple the local CDB transaction from the device transactions. This means that control can be handed back to the user as soon as the fast transaction to CDB is completed, and the commit queue will handle the slow device transactions. In this sense, commit queues are very simple. And the change is that you're moving away from atomic synchronous to asynchronous transactions. What does this mean? It means nothing more than you need to wait for confirmation that the transaction has completed all down to device level, and you need to retrieve the result. I will get back to this later, as it is important when using commit queue and LSA. And the last thing you want is a failed transaction and not knowing about it. I will continue with a few words on LSA. And LSA is the feature in NSO that I think we have to actually do the actual scaling. And it allows you to split the load on more nodes. And simplified, it is NSOs stacked in 2 layers and a single NSO on top. The top node is the CFS layer, short for customer-facing services, and is the northbound view of your services. The lower layer of nodes is the RFS layer, short for resource-facing services, and is the southbound view of your services towards your network devices. The purpose of the RFS layer is to split the load of device configuration and device transaction on multiple nodes. The goal of LSA is to scale, but still be able to see the stack of NSO nodes as a single system. So what LSA brings is better integration between the 2 layers, between the CFS and the RFS. This integration means you can basically manage all your transactions towards the top node without the need of knowing anything about the lower nodes. And from an orchestration perspective, it is not that different from using monolithic NSO system using commit queues. The change from moving from a monolithic system to LSA is similar of using stacked services, which, by the way, is a good design pattern to structure your services. The analogy of stacked services in LSA is that the top service, almost unmodified goes into the CFS node. And the lowest services go unmodified to the RFS nodes, and what I would like to call a device model copy is put into the CFS node. But how does LSA help scaling? It means you can divide your devices on multiple NSO nodes. This will reduce the individual CDB size and allowing for increased parallelism towards your devices. It also makes it possible to run more commit queues in parallel. If you have other things that use a lot of CPU, it will be better as well. LSA helps for partitioning multi-domain orchestration, as it allows for independent development in different domains. So then comes the big question: when should you start using these features? I would say the rule of thumb is to start using commit queues is when the desired transaction throughput no longer can be maintained. And one strong indication is that you have devices with long commit times. The decision of moving to LSA is not as clear, but 2 indicators we know of is you have a massive number of devices to manage, and the size of CDB slows down the NSO system in some way. The implication of those is not necessarily a reduced transactional throughput. It can also be a maintenance issue, like a longer system downtime is needed, like upgrading a NED and migrating devices. The move to LSA is more or less a decision. What is good to know is the implication of this decision. There is a slight change in service design, adding some overhead, but nothing significant. As I mentioned before, the biggest change is not the use of LSA itself. It is the implied use of commit queues, as it is more or less required to take advantage of the scaling LSA provides. This means that the majority of the transaction will be asynchronous towards the devices. The asynchronous behavior mean you will get an immediate result with the commit queue ID, but nothing about it if it was successful or a failure. Now you need to monitor this, and you have commit queues where you can get the actual status and also the completed result. And it is always good to keep an eye on the alarm list, as most device failures end up as an alarm. And polling those is often not a desirable solution. Instead, you can subscribe to notification to be informed about any changes. And the most common question around LSA in commit queues is if we have any best practices to recommend. And the sad thing is that often we say it depends on the use case. But now to address this, we have initiated work around best practice for just commit queues and LSA, as this is a huge gray area, as the number of permutation of use cases, you have design choices, requirements, configuration options, and more. And this almost grows to infinity. So we think it is very important that we have started this work. Our first step will be to provide a playground environment for LSA and commit queues that's intended to be easy to use and an environment where you can test how things work. In this environment, it will be possible to dynamically follow and see how a transaction is ripped through the LSA nodes down to individual devices. And you will be able to accept the rejection of transactions at almost any level. And this makes it possible to test scenarios and behavior in a controlled, reproducible way. And we hope to be able to publish this in a not too distant future. For details around commit queues, I recommend the presentation that the former colleague Dan Sullivan did during Dev Days last year. I think it's very informative and educational, so very good recommendation. And all this is available online. Thank you for listening, and now I will stay tuned for a Q&A session.